Friends, in this session, we will discuss about the design of control systems with the PI, PD and PID controllers. PI means proportional integral control, PD means proportional derivative control, PID means proportional integral and derivative controller. And first we will make a comparison between PI, PD and PID controllers. In the case of a feedback control system, controller is introduced to modify the error signal and to achieve better control action. You know that in the case of feedback system, at the error detector there will be an error will be produced, and introduction of the controller will modify this error signal so that the overall system performance will be achieved. Overall better system performance will be achieved. Okay. Next, we will find the effect of proportional controller. Actually, we are making the comparison between these three controllers. What do you mean by an effect, proportional controller? In the case of a proportional controller, the output of the proportional controller is proportional to the error signal. And usually these controllers are introduced in the forward path of the control system. That means that is introduced in the open loop portion of the control system. So the output of the proportional controller is proportional to the error signal. And the transfer function of the proportional controller is represented by Kp, and Kp is called the gain of the controller. And the proportional controller actually amplifies the error signals, and it increases the loop gain of the system, which in turn improves the steady state tracking accuracy, improves the disturbances signal rejection, and also it will improve the relative stability. But the drawbacks are it decreases the sensitivity of the system and it produces constant steady state error. So that is the drawback of the proportional controller, which is indicated by P. And next we will see the effect of PI controller. PI means proportional plus integral controller, and the output of the PI controller consists of two terms. One is proportional to the error signal and the other is proportional to the integral of the error signal. That is why it has got the name PI controller. That is, one part is proportional to the error signal and other is proportional to the integral of the error signal. PI controller introduces a 0 in the system and increases the order by 1. See, usually the PI controller is introduced in the open loop part of the system. So when we are calculating the gain, its overall gain will be changed by the introduction of PI controller, or overall transfer function will be changed due to the introduction of the PI controller. Actually, it introduces a 0 in this system, and also it increases the order of the system by 1. And also it increases the see, when the order is increased, the stability of the system is decreased. Actually, the order and stability has got one relation, that is, once the order is increasing, stability will be reduced. So PI controller increases the type number of the system by 1, and it increases in the type number reduces the steady state error. That is why the steady state error is reduced in the case of PI controller. It is achieved by reducing the, it is achieved by increasing the type number of the system. The transfer function of the PI controller is indicated by the Gz of S, that is given by the equation Kp into 1 plus 1 by Tis, where Kp is the proportional gain and Ti is the integral time. And next we will see the effect of PD controller, and PD controller means a proportional plus derivative controller, and it produces an output signal that consisting of two terms, and one term is proportional to the error signal and the other term is proportional to the derivative of the error signal. That is why it has got the name PD, or proportional derivative controller. And the transfer function of the PD controller is Gc of S is equal to Kp into 1 plus Tgs, where Kp is proportional gain and Td is derivative time. The block diagram of the unity feedback system with PD controller is shown in the figure. See, you can see here that the PD controller is shown like this. That means it is the gain of the, or it is a transfer function of the PD controller, and this transfer function is introduced in the forward path or in the open loop of G of S. See, this is a feedback system, and in this the PD controller is introduced here, and its gain is Kp into 1 plus TDS, where TD represents the derivative time. We will analyze the system in the next slide. First we are doing a comparison between the different controllers. PD controllers introduces a 0 in the system like that of the PI controller, like that of the like that of the PI controller, and it also increases the damping ratio. Addition of the 0 increases peak overshoot and reduces the rise time. Effect of the increased damping ultimately reduces the peak overshoot. See, here a 0 is introduced in the system. Due to that 0, peak overshoot will be increased, but you know that it increases the damping ratio also. The increased damping ultimately reduces the peak overshoot. So the effect of the introduction of addition of the 0 is reduced by the increase in the damping ratio. PD controller does not modify the type number of the system, but you know that in the case of PI controller, type number is increased, and PD controller does not modify the steady state error. Next one is PID controller. It consists of proportional, integral and derivative controller, and here improved system performance is achieved with the use of three types of control. And proportional controller stabilizes the gain, but it produces a steady state error. The integral controller reduces or eliminates the steady state error, and the derivative controller reduces the rate of change of error. So these are the comparison of different controllers. Now let us see how this PI